Hi everybody, welcome back to another Cloud Lunch and Learn. This is our fifth session in the So You Want to Be an Azure Solutions Architect Expert series, and today we're going to look at data and storage. So with that said, I will hand over to Dwayne.
Thank you very much, Lisa, and good morning, good afternoon, good evening, wherever you are attending today. So yeah, let's get into it. As Lisa said, we're on the home stretch. We've got this week and next week in the series. So hopefully everybody's feeling really good about the objective areas of the Azure Solution Architect Expert exam. Today we're going to be covering data and storage objectives. So, I think we've got a lot of returners on here. For those of you who don't know me, I'm a senior cloud training architect at Opsagility and a Microsoft certified trainer and regional lead. And you can find me on various social media platforms. So what we've been doing for the past 5 weeks up to this point is going through each of the objective areas, which are part of the links here on the slide. You can find them very easily on Microsoft Learn for becoming a solution architect expert. The 2 exams right now, there is the 303 and the 304 exam, which are the new numbering for the 2 exams. They are in beta. The currently active exams are the 300 and the 301, which are the ones that you would, from my standpoint, would preferably take right now because you would get your immediate results. So keep that in mind. There probably will be some time where both of these exams are active anyway. They're saying that 300 and 301 will retire at the end of September. For example, right now, the Azure Administrator exam, there are actually 2 active exams, the 103 and the 104. They haven't retired the 103 yet, so you could prepare or take either one of them. Right now, the 303 and the 304 are strictly in beta, and if you wanted to take them, you're not going to get those results until 300 and 301 are retired. So we've been going through each of these objective areas over the last 5 weeks, and today we're going into data storage. So we'll talk a little bit quickly about data evolution, and then we'll go into the different, into Azure Storage, into some topics around relational and non-relational databases, and big data options, and how you choose those different options, what you go through to do that. One of the things around the Azure Solution Architect exam to take into account is that the exam itself brings a lot more of that databases into the topics, and it starts to bridge that gap between architecting for data and then the data engineering certification track. So that's one key difference between any of the other exams, or if you've taken the Azure Administrator exam, that's really what starts coming to light within these exams. And from a high level, from an architectural standpoint, you need to understand what solutions and services are available, and that's what we're going to cover here today. We won't cover a whole lot on databases just because we did cover that. It covers a bit on the main database topics on the platform session a couple weeks ago, so you can go back and listen to that recording to get some more content on that as well.
Dwayne?
Yes.
Just very quickly, how are Microsoft doing examinations in our current lockdown situation? Can you do them all online? Is that?
Yes, all the Microsoft exams, you can do them online, and that is, I find it my preferred method at this point, where I sit at my kitchen table and take an exam. You do not have to go into a Microsoft testing center anymore. Pearson VUE in most countries, I don't know if it's with every country, but I know in most countries it's available to take with home proctoring. The key point to remember when you take the exam is make sure you have a clean workspace. I have heard that they're a little bit, they've been a little bit less stringent about taking it at your desk with multiple monitors. I think probably because of the the fact that everybody's working from home now and may not have a clean space with families and everything that are home, that they'll just make sure that you have disconnected all of your separate monitors, and you're just working directly on your laptop. So that's key to know. Phil, that's a very good point. Do not read the questions out loud. I actually got I have a habit of putting my hand over my mouth when I think, and I got had a proctor chat me one time during a test to get my hand away from my mouth as well. So keep that in mind as well. Yeah. Yes. Thanks, Jonathan. Yep. Exactly. That's what I've heard. You have to, the proctor will want to see if you have a secondary monitor, that it is disconnected. I've taken it in conference rooms at an office before as well, and they've made me sit with my back to a monitor and make sure that it's also disconnected from power. So those are some key things to remember, that they want to make sure you have a blank workspace. You don't have any books or papers or anything on there. It has to be a clean, almost sterile workspace. So keep that in mind. But yeah, home proctoring is a great way, because I'm sure most of you out there have better devices than what the testing centers have, for the most part. Usually those are old machines that have been phased out of their general work environment. So they're probably usually pretty old environments. Yeah, make sure you don't have any kids around. When I take them during the COVID times here, I take them at about 5 o'clock in the morning before anybody gets up in my house. So that's usually what I do. So, and there are some, I think Tim Warner wrote a blog article about preparing for a home exam a few months back as well. So there are some tips and tricks that some of the other people in the community have written articles about as well. So let's get into the topics. And if we have some time and everybody wants to talk more about it, we'll probably have some time next week, and we could talk about some exam tips and tricks as part of the labs. I'll work that in as well, rather than taking up some of this content time talking about it. But good question around exams at this in this interesting time in our lives. So key thing around data and data evolution is that as we get more and more online, data is becoming much more highly abundant, and there's becoming more and more connected devices. So more data that's evolving and data that's ingesting into our lives. And what do cloud services have to do with that? And the key thing around cloud services is versus on-premise services is the ability to scale quickly, the ability to provide high availability, scale, supportability, and all of the uses of cloud services to increase that data usage and give it a place to be stored in a large and quick amount of time is key. And that's really where we're really seeing more and more cloud use cases, is because of the amount of data. Companies do not want to continue to buy network storage devices and continue to add as their data adds. They're offloading a lot of that and even archiving that to cloud storage to save space in their own data centers, and it gives more credence to moving to utilizing Azure and other cloud resources. And then the technologies that we have in the cloud help to, as we change our usage and approaches of loading and transforming that data from a standpoint of loading it and presenting it right away, rather than the typical style of taking that data, ingesting it, making sure that we transform it to a usable level, and then loading it into visualizations. We're doing that a lot more real time now. So the ability to increase our processing power rapidly within the cloud helps to accomplish that within our environments. And then we talk about our types of data. So we have many different types of data. The typical SQL database type of data of structured data, where we're looking at tables and we're looking at rows and columns. Then we have much more semi-structured data coming out there where we're providing, and we've got tags and keys, what we think of as NoSQL data, but still utilizing database type structures. And then our unstructured data, which is probably the biggest amount of data that we're getting in there, and that's our data of video files and JPEGs and what our general user population is using on a daily basis, and just dumping into storage and saving in storage. So when we talk about the Azure environment, we have multiple data sources within our platforms and within the platform of Azure. And the first part of this presentation, we're going to focus on the bold topics on here, and then we're going to hit the other bullets here quickly in the second half. But it's key to understand what Azure has in terms of storage and data sources for storing data and utilizing data. And those are the typical Azure storage, Azure Data Lake, Databricks, Cosmos DB. We talked about SQL Database and Cosmos DB a couple weeks ago. And then Azure Synapse Analytics, which was a renaming of SQL Data Warehouse. So if anybody's looking for SQL Data Warehouse and information on SQL Data Warehouse, make sure that you're looking for Synapse Analytics. And then other platform services for that ingesting of data. We have the Stream Analytics, which we won't talk a whole lot here. That goes more into the data engineering side of things, but I just really wanted to provide that broad brush of those services so that you have that level of understanding here. The big key in terms of understanding storage within the Azure ecosystem is Azure Storage. And a key point around whenever you're talking about Azure Storage or understanding Azure Storage is that Microsoft has their general purpose version 2 of Azure Storage, which is the preferred method. And when you go to create a storage account, you'll see that there's still blob storage and general purpose version 1 within there. Those are being deprecated, and really are just legacy usage storage accounts that really general purpose v2 provides the best of both of those in one storage account. So any storage account that you're creating in the Azure environment should be general purpose version 2, and that's what Microsoft's recommendation is. If you see any questions around what type of storage account to choose, that would be where you would default to. And within an Azure storage account, when you stand up that general purpose v2 account, you have 4 types of storage that come into play that you can utilize within that single storage account in different manners. And you have your containers or blob storage account, which is your object storage, your unstructured data. You can make it look like a container or a folder structure by creating different containers. A good example of a blob storage account is OneDrive. We make it look like a Windows Explorer, but it is really just a blob storage, and when you create a folder in OneDrive, you're just creating a container and you're dropping all that information into that container and creating a folder structure based on the metadata of what you're putting into that account. So you're making it look like your typical Windows Explorer folder structure that we work in on a daily basis on our devices, but it is blob storage. It's unstructured data. So you have the ability then, that metadata, you can search on anything rather quickly. If you ever searched in OneDrive on any topic or any keyword that might be within your files, it returns information a lot quicker than what you get using Windows Windows Explorer. So so it's very, very helpful from that standpoint. File shares is more typical to our file environment, our file storage type environment, where it's a more structured environment. It's that file and folder structure. It's what when you mount a disk to you mount a disk, it's going to use file storage, so it looks and feels like how you would handle a file server in your environment, and it allows you to map drives to users using the SMB 3.0 protocols. So you have the ability then to utilize file shares within there and create a file server type structure that rather than standing up file servers within your environment as well. And then two of the less discussed Azure Storage services within GPv2 is tables and queues. And tables provide that semi-structured data. It looks very similarly to just a Excel spreadsheet where you have your rows and columns in there, and then queues are generally your log data and information within there that's very unstructured data that you can store different files for that come in for like messages and messaging and things like that. So so just some things around making sure that you understand the 4 different types of storage within the environment. Within Azure Storage, the 4 different types, and understand where they fall in terms of usage and structure. Key thing around Azure Storage is the security, and when we get in, and I'm going to demo and show a little bit of this at the end of the presentation, but understand that you should never put a storage account on anonymous access to avoid because every storage account has its own web URL. It has to have its own unique name from the entire Azure environment, not just within your own environment. It doesn't do a check when you create your storage account. The only exception I would say in terms of anonymous access is if you have a specific storage account that is strictly for website images. That would be a situation where it doesn't do you any harm to make it anonymous, and there's no need to deal with shared access signature keys to have people be able to see your images. That's a good question, Gobel. So real life data were tables and queues. So queues would be used in terms of if you're ingesting messages and things like that. That would be usage of queues. If you're using that storage account for some sort of basis for, say, help desk messages, and queues will allow it to handle a first in first out type structure within queues. Tables, a good example to that is you can use Azure Table Storage for if you were creating a marketplace app for Azure, and you want to capture a form within the Azure marketplace and present that to you. So that's it will gather all that information very similarly to how it would load into like a CSV file. It looks very similarly to what a CSV file structure would. So thanks for that question. That's a great question. Shared access signatures are used then when you're not doing anonymous files, when you set things to be private and you need to share information. So when you create a OneDrive sharing key and you put an expiration on that and you give somebody a link to that OneDrive file, you're essentially creating a shared access signature. You are giving permission to that person for access. It could be just read access, it could be write access, it could be delete access. You set those up and you can give those an expiration date, and you have the ability very quickly revoke that if you find that it's been compromised, that somebody has given that link to somebody that's not authorized. You could very easily go in, revoke that key, or revoke that shared access signature, or change the key on that, so that that previous link is no longer valid, and you limit your amount of exposure of that data source. Replication, we talked about replication a couple weeks ago when we were talking about replication and backup and continuity. And there are 4 main types of replication. There's local redundancy, zone redundancy, global redundancy, and then read access global redundancy. And there's some different pieces within there for, that add a couple additional tiers around zone redundant, global storage, and things like that. But those are the 4 to keep yourself to understand that with local redundant and zone redundant storage, you have 3 replicated copies. Global redundant storage, you have 6 replicated copies, 1 local and 1 in a global pair of your local data center. If you have read access global redundant storage, you can actually read off of that redundant location as well. So it's good for geographically spread out users that need to read database information and you want to avoid latency. Replication, as I stated in the previous session, is not backup, and we'll talk more about how to control backup and help to handle your backup in a second. But it is what I said, replication. So 3 copies of a bad file that is corrupt is 3 copies of a corrupt file. So you need to put other backups in play and abilities to protect your data, other than just having, saying, oh, I've got 3 copies that Azure's keeping for me, I'm fine. But if somebody deletes it, or if it gets corrupt, it replicates that corruption across all of your redundant storage environments. And then one of the ways to avoid an accidental delete is soft delete. And that is very similar to when you delete a file on your local device, it putting it into a recycle bin. And you can set that to hold that information for a day up to a year. And then another way to protect your data and to provide retention policies around your data is data lifecycle management. And this helps because you can and this helps to control cost, because you can continue to move data that is not being accessed on a regular basis to different storage tiers to avoid and decrease your cost of storage. As we ingest more files and data, we're increasing our cost, and storage is becoming one of the probably biggest costs within the Azure environment. So the ability to move from the 3 tiers, which are hot, cool, and archive, help to decrease that cost. Because if you have a file that's in hot storage and you move it to cool, you've decreased your cost by 50%. You move from cool to archive, you've actually made that storage 10% of the cost. So, for example, hot storage is about 2 cents a gig. Don't quote me on the cost. I think it's actually might be less than 2 cents. When you move to cool storage, it's 10 cents. When you move to archive storage, it's 1/10 of a penny, or say it's a penny, just to kind of give you that idea of what it is. So it really helps to decrease your costs. When you move things to archive storage, when you move through these tiers, you actually get charged a cost of accessing that information. Not as much with cool storage, but when you move to archive, it's very similarly to if anybody's ever archived physical files to, say, like an Iron Mountain, and you need to access those files. Iron Mountain charges you to grab those files. That's very similar to archive. Once you move things to archive, they're not immediately available anymore as well. It takes about 24 hours for you to be able to access that data. Hot and cool there's not a whole lot of difference between the accessibility of it. You can still access files in a cool environment. It might cost you a little bit to access it depending on how many files you're accessing. I think they give you a certain amount of files, but once you go over the amount of data that they're telling you can do for free, it becomes a little bit of cost. Elio, that's a good question. I will actually cover that a little bit in our demo when I get to that, on how to move data from one tier to another. You can do it automatically, or manually, but I'm going to show you how you can manage your life cycle automatically in our demo. So let's get into databases a little bit, and we'll talk about, we have your relational and your non-relational databases. And like I said, we're not going to talk a whole lot about this. I'm going to cover a little bit more about SQL database in a second, but we have relational and non-relational databases. And when we talk about relational databases, it's the very structured data. It's the SQL type databases that Microsoft has had for years, that if you're a DBA and you've worked around databases, SQL. And then we have our non-relational data structures, which are semi-structured data. There's not a defined schema. It's using keys and tags rather than fields and tables. Even though they do have some sort of a structure, they're not recognizing that structure, and there's a lot more dynamic referencing between tables, between databases, utilizing the semi-structured data. And those are those NoSQL databases, and Cosmos DB kind of falls into one of those. And that's kind of your key database to understand in terms of non-relational databases as part of this exam, is really Cosmos DB. But there are a lot of other ones as well. And if you noticed the article that I put out yesterday to accompany this, I did put a link to the entire database portion. So it's good to familiarize yourself with the different types of databases for this exam, because like I've told you over and over again, I believe during these sessions, is databases is a big part of this exam. It's probably the biggest delta between the Azure Administrator exam going into the Solution Architect exams. One thing I haven't talked about in any of these sessions is how SQL works within the Azure environment. And I touched on this a little bit in the platform session, but what I focused mainly on was this first one here, which was Azure SQL Database, which is the fully managed platform of Azure SQL, or of Microsoft SQL within Azure. And that, if you have strictly database data, structured data that you need to put into the Azure environment, that is the direction you need to go. Some different options, though. Microsoft has 3 different options for SQL within Azure. The middle one is similarly, it is kind of a hybrid of platform versus just an IaaS type, where it does provide all the SLAs and everything, but doing a managed SQL instance is a single database rather than the full platform service is you're just getting the compute power. You're not using technically any specific instances. It's spread across the entire platform infrastructure for SQL that Azure has built. Managed SQL instances, you are in a way reserving an instance for your database, so you have a little bit more control over it from that standpoint. But it does provide you with all those platform type services. So if you need to stand up databases on a global scale utilizing SQL, you could use the managed SQL instance and get all that high availability, the automated backups, the automated updates and patching to decrease your management overhead that you get with Azure SQL, but you get it on a much more granular level. And then the SQL virtual machine is just standing up a virtual machine and putting SQL software on it. and that is the IaaS option. That's very more typical experience to what you would get on an on-premises type SQL environment, where you're going to stand up, you're going to manage the SQL engine, the SQL software, and if you have databases that require more custom tuning and things like that, that's where you're going to use the SQL virtual machines. And we talked about Cosmos DB again in the platform, just kind of as a review to remember. This is the globally distributed database service. It has APIs for SQL. It's important to understand what APIs it does have, so that you can utilize. You might see a question around, what APIs. Choose the APIs for Cosmos DB. Very high availability, low latency, global scalability, multiple consistency levels depending on how your database works. Are you ingesting data on a constant basis? You might need strong or boundless, stateless type consistency levels. If it's very static or very slow to grab new data, that you don't need real quick access to data, then the eventual or consistent prefix might be more of an option. It's important to understand what each of those are and what the scenarios might be to utilize them. And we're going to quickly mention a few of the other types of storage accounts here, and then get into our demo. And those are really the big data type services when we start talking about ingesting large amounts of data and processing those on a quick basis. That's where we start talking about Azure Data Lake storage, Databricks, and then Synapse Analytics, or the former SQL Data Warehouse, as well as Azure Stream Analytics. All of those, and Data Factory, and all of those big data services fall into when you're ingesting large amounts of data, and you need to process and store those quickly in a manner that then you can access and transform and present that information in a quick basis as well. So that's where all of these start coming into play. I'm not going to spend a whole lot of time on it. Like I said, it's more around the data engineering exams, but it's important to understand the use cases for each, and to review what they do and review the overview of each of these, so that you can understand how they're utilized. Data Lake storage is actually a subset or an expansion set of Azure Storage, and we'll show that in a moment as well. And how do we choose what storage we're going to use? It's very important to take into account, what the characteristics are of our data. We talked about the different characteristics of structured or unstructured object storage and all of that, and when and how we're going to use it, and what the key features of those storage services are, how we're accessing and ingesting and presenting and querying that data, and then ultimately we need to take into account how we're securing that data and how we're protecting that data. We talked a lot about security and defense in depth last week, and what we're doing to protect our data from being exposed. And we'll talk about with storage accounts and shared access signatures here in a second. So let's go into the Azure Portal, and we'll talk a little bit more about protecting our storage accounts. So I've already got a storage account created here, and the main thing I wanted to show here is in the storage account is here. If you scroll down on the left side, you can see here's our blob service, here's our file service, our table services, and our queue services. So we've got all of these right in here. So I don't have anything in here right now, but if we wanted to, from a blob standpoint, add a file in here, I will add a file called images. And just for the use of this, I'm going to make give this anonymous access and make it public. And you can see here that if I do that, it gives you a warning that, hey, this is going to be read by anybody that gets my storage account. So I'm going to create this, and I'm going to real quick go into images, and I'm going to just upload an image to this file real quick. So I've uploaded this file. So since we did anonymous access on this file, if I was to go to this file and grab my URL here and copy this and go back into my browser, my image is going to come up on the file. So we've decided, you know what, we don't want to do this. We don't want this to be anonymous. So I'm going to go in and go into my container again, and I'm going to change my access level, and I'm going to change it to private. So this is successfully changed. So if I now go into my image and try and view it, it's going to give me it's going to error out. So now I've protected my file. I've put a level of security on this file to avoid it being exposed, because like I said, every file, if you go in here, it has a unique URL. And you know, it's just a plain old URL that if somebody found out what my storage account is named and what my file is named, if it's anonymous, they can find it, because this blob.core.windows.net is in every file, is in every account, and is a standard naming convention that that Microsoft utilizes. So let's say I need to give somebody access to this file, though. I can very easily do that by sitting here and generating a shared access signature. And here you can, like I said, you can create multiple permissions for that. I'll just leave it as a read. Let me start it at a previous time, and I'll give access till this afternoon. Important here in your start time that you kind of adjust it to be a few minutes in the past. That way, when you generate it, they do have access to it right away. I have it. You can, if you want to make sure that just a single user has access to it on their home network, you can find out what, ask them what their IP address is and put that in here as well to give you an additional protection. And then here you can see you've got your keys and your typical, your standard 2-key system here, where you have two different keys in here that are utilized, and you can very easily, like I said, if this gets exposed, change it from key 1 to key 2, and that makes the shared access signature that was previously provided it's going to immediately expire. Shared access signatures do have an expiration date. They all do. So you would, a non-expiration date, you might as well make it anonymous at that point. So if you're providing a shared access signature, you want to have an expiration date. If they need access for a year, you can give them a year. You have whatever data on the calendar that you can put on there. So, but if it's something that the person needs access for a long time, you can put multiple years on there, but you cannot make a shared access signature without an expiration date. And then if I do generate my token and URL, it's going to now create that token. It's going to create that URL that I can copy to the clipboard. And if I was to use that, my image is going to show up again. So that's how you create a shared access signature. It's very easy to look at a shared access signature, and this is something to take into account. You can actually see here, we have when it is starting in terms of when it's available to when it is no longer going to be available right within here. Let's try and zoom in here for you.
Dwayne?
Yes.
Can you provide that access without an expiry date?
Yeah, I was just answering that. No, you cannot.
Sorry.
What you would need to do to provide that access is just make it anonymous, and that's a non-expiration date, is make it anonymous. When you create a shared access signature, it's going to require you to create an end date, but that end date can be long distance in the future. So when you break apart this URL, you can see here, and this is important to understand. Here's your level of permission for read. If there was write on here, it would be an RW. It has your start times, your end times. So if somebody that has a shared access signature is wondering how long they have access, they could very easily look at this URL and figure it out. And it's important to be able to comprehend this particular piece of the shared access signature, because you may get a question that they give you this shared access signature, and it's going to ask you what type of access that person has within the shared access signature. So keep that in mind. All right. And then very easily you can, within the shared access signature, like I said, I can change the key. If I change the key and regenerate, and I go and try and use my previous key that I pasted in here, no, it's still got the key. Sorry, failed with the demo there. If I can very easily here though, so I can delete my blob. That's going to delete my blob. I could easily here put this to expire. And if I've expired this, now I can go in and I won't have access to it anymore. It hasn't refreshed yet. So anyway. Just got to give it a chance to refresh. But anyway, so that's how you'd use shared access signatures. From a standpoint of soft delete, which I also wanted to talk about, mentioned that soft delete acts as though like a recycle bin within your environment. And here you have your data protection, and you can enable that. And this has retention policies in here. In file shares, you can see we have a soft delete within here, where if we can enable that soft delete, and like I said, you can do 1 day to up to 365 days of having that recycle bin. And so that's a way to protect yourself from accidental deletions. If you have the ability then if you have that enabled and somebody does delete the file, then you can go back and you can go into your file structure, and you can see here there's a show deleted shares, and if something's been deleted, it will show that, and you can restore that right within here. So that's very helpful from that standpoint. And then lifecycle management is within your blob storage account, and here is where you can then create an automated retention system within your containers and within your object storage very easily by just creating a role name. And here we can very easily say, if a blob hasn't been touched for 30 days, I'm going to move it to cool storage. After 180 days, I'm going to move it to archive. And, and after 7 years, which I'm going to have to do a little bit of quick, let's just say a year, because I can very easily say 365, you can actually delete your blob. And here you can also manage your snapshots as well for your virtual machines, and delete those snapshots after a certain amount of time as well. So this would enable that retention policy that if your data is not touched for 30 days, it's going to move from hot to cool storage. And this is going to look at every object and every file that is within your storage account, within the blob containers, and it's going to automate moving that information automatically. So very helpful from that standpoint. And last thing I wanted to show before we open up for any questions is how do we create a data lake store? And that's very easy within creating a storage account. To create that storage account, again, you can see we have our different different types here, but it's going to default to GPv2. You're going to select GPv2. And if we go into the advanced tile here, we're going to see here the Data Lake Storage Gen 2 and our hierarchical namespace environment. And if we enable that, we are now creating, instead of a standard storage account, we're now creating a data lake. We're creating a data lake storage account. So it's not your typical storage account with your files and folders. You now have a data lake for a large hierarchical storage account for handling large and ingesting large amounts of data and storing large amounts of data. And that'll take a minute to deploy. It takes a little bit longer than a storage account. Storage accounts get deployed rather quickly. A data lake takes a little bit longer because it's building that structure, but still doesn't take that long. And if we go into our data lake, we're going to see a little bit different look here, especially around our data lake storage. We still have our lifecycle management, and we still have our ability to create containers within blobs. But you saw a few more selections in there in terms of data protection and things like that. There's no longer a soft delete function within the data lake that you have within the blob containers. But if you need a data lake, you create that data lake, that storage account with a data lake, you lose the blob storage part of your storage account. Now you can create another GPv2 for your standard blob storage, but you still get your files, tables, and queues that you do with a standard GPv2. It's just really replacing your blob storage containers with data lake storage containers. So those are the main things I wanted to touch on. And so let me look through here and see if there's any particular.
There's been some further discussion on how best to manage that access.
Yeah, so yeah, in terms of managing access, you have different options. You can bring in Azure AD with many of your accounts. Obviously Azure AD we talked about last week is the identity structure within the environment. The problem with if you're giving depending on whether you're using the storage accounts for people outside of your organization and giving access to that, you really can't use Azure AD. Do you want to give all of those people guest access to your environment just to read a file or a folder within your storage account? That's why shared access signatures provide you with a much more dynamic and low management overhead piece to that. And you do have the ability, you can build those shared access signatures and tokens and things into APIs and service principals as well. So you have to get to Gopal's question around APIs. You can build those shared access signatures and those URLs into your applications and things like that. But you do have to take into account, and things to take into account are, is this information that is for public consumption, or is it something that that I'm standing up on a short-term basis and need to put an expiration date on? And then Venkat, yes, Key Vault is a definite place where you can manage your keys safely and avoid exposure of those keys. You can bring those into the environment and utilize those as well, rather than utilizing the inherent keys that are given to the storage account. When we were talking about Key Vault last week briefly, it did mention that's Microsoft's way of creating separation of duties of Microsoft managed keys versus customer managed keys in a Microsoft and Azure service, where you're going to manage your keys and your secrets within the key vault yourself. All right. I think we got all our questions answered, and we've got next week again. We'll go into the portal a little bit, talk a little bit about labs and testing, and the the final preparations of going into your exam and being ready for your exam. We'll talk about next week.
Awesome. Do you want to also mention the quiz, Dwayne? And I will share
yes.
the link right now.
Thank you very much. I'm sorry. And I know that our winner from last week is on the call, because I did see a question from Elio. Elio Panting, you won the quiz last week, so I'll be contacting you at the email address that you left in the form about your prize. So look forward to that, and we'll then Lisa has put the quiz for this week in there. There's only about 3 questions. Hopefully you're paying attention, because they were some things that I specifically mentioned during the discussion. So we'll see how everybody does on the quiz this week, and we'll announce the winner for that one next week.
Excellent. So guys, you will see that I have bombarded you slightly with links in the chat. First of all, we would love your feedback on our Cloud Lunch and Learn sessions. So there's a link there for that. There's a link to get Microsoft learning materials relevant to this session from Microsoft. And also, it's a really great piece of feedback for the Cloud Lunch and Learn team. You'll be able to find the presentations, etc., shared by Dwayne in our GitHub. I've posted the link to next Friday's session for you guys to get signed up and get it in your calendar. And then, yeah, finally, we've shared the quiz link for you guys to have a go and see who wins next week. Awesome. Okay, so I'm going to stop the recording now. So look forward to seeing you guys next week. Thank you so much, Dwayne, for another awesome session.
Thank you very much. Thanks, everybody. Appreciate your time today, and enjoy your weekend.